record today. If that's radical form, what is exponential form? Right, we did talk about this at one point. There you go. Okay, so the index comes out and becomes your denominator. Whatever is on the inside, whatever exponent's on the inside is your numerator. Okay, and these are interchangeable, and occasionally you're going to want to be in exponential form. Okay, so you want to be able to do that. Is there any questions on that? Okay, so there's a couple things I want to get straight first. As of today, can you do this? Can you take this? What is the square root of negative 4 if you can do it? You're shaking your head. Why can you not do this?
You can't do negative.
Because why?
Well,
She's right. You can't. Because why? What is the question? When you're taking a square root of a number, what are you trying to find?
What times itself
Gives you that inside number. So what times itself gives you negative 4? There is nothing right now, right? Because negative 2 times negative 2 is positive 4. Okay? So here's something that we need to make sure we understand. If the index is an even number, and we'll call it the radicand today since we're talking about it. So if that inside number is negative, you can't do it. Okay, so no matter what it is, so you can't do the square root of negative 4, because again, if there's no index out there, remember it's a 2. Okay, can't do the square root of negative 4, you can't do the 4th root of negative 4. You can't do the 8th root of negative 4. Okay, is that all right? And so some problems, that'd be a great problem for you, Patrick, because you just say, hey, you can't do it, empty set, no solution, say something like that. Okay, however, if you got a calculator on you, you can verify this. Can I go on here? So let's say we did the cube root of negative 8. Okay, if the square root says what times itself gives you that inside number, the cube root says what times itself 3 times gives you the inside number. So now if you typed it in your calculator, well, it didn't say 2, it said... Okay, so... right, so if you want to check if it can be evaluated, you can do it that way. Just make sure you use parentheses. So negative 8 to the 1/3 gave you what? Gave you what? Okay. Or, with this calculator, what you can do is, I believe it's in the math column. Hit the math button. And I would even just go down to the 5. I mean, you could do 4 if you want, but if you... All right, so you can go to 5, then you can enter in whatever root you're looking for. Okay, so 3 to the negative 8, that should give you negative 2, doing it that way also. Is that okay with everybody? All right, so different, when it's an even index, you can't do a negative. Every odd index, though, you can do a negative. Okay, so... right, if the index is odd and the radicand is negative, That's okay. All right, so we gotta get that taken care of. I'm gonna come back and talk a little bit more about how to deal with these, because sometimes that negative is gonna throw you off. But if you notice, the answer was negative, okay? So if the inside is negative and the index is odd, your answer will be negative, okay? So just keep that in mind. How's that got it? All right. Okay, so the first thing you want to do is break it into its prime factors. What the heck does prime mean?
Like 7 times something like
So 7 is a prime because its only factors are 7, or itself and 1. Okay, so the first prime number is 2. The second prime number is 3. The next prime number, 5, then 7, then 11, 13, no, 17, 19. Okay, there's no more even primes, right? Okay, so those are primes. So that's the first thing you want to do. Okay, so if the index is a 2, like the square root, then you're looking for groups of 2. If it's the cube root, you're looking for groups of 3. Fourth root, groups of 4. Okay? So it all depends on the index. But the first step is always get it down to its prime. Okay? And this is really a generic way to think about it. It'll make more sense when we do it. If you can't make a group, then it has to stay inside. Right? Can't come out and play like all the other factors. Right? Probably didn't clean your room. Factor. Didn't walk the dog again. Or whatever other chores you guys skip out on. You had to stay inside. You weren't allowed to play. Well, of course, you guys don't even care. No one goes outside anymore, from what I understand. Right? I feel bad for you guys all walk around like this all the time. I feel bad. You guys don't even know what you're missing out on.
What are we missing out on?
It's like life. So, it's fine.
Mother Nature.
Mother Nature, you know. Did you know that Mother Nature's always in high def? Like, you don't have to get the right video. It's like always like that.
It's crazy.
Isn't it nuts? It's nuts. Because we can do it because it's positive, so you can do all of these that are positive. Okay, what is the index on this problem? 2. Okay, it's not written, so it's 2. But the first step should be, either way, find the prime factors of 45. I like to use a factor tree. You don't have to, but you need to come up with the prime factors. And I'm going to break these all the way down, and I'm going to explain this one a little bit more so you can think about it in a different way. But what are give me 2 numbers that go into this.
9 and 5.
All right, 9 and 5. Can you break any of those down further? 3 and 3. Okay, if you've done these before, which you should have, you may be saying, why are you going this far? And if you don't know why you could stop before you got to 3 and 3, then that's fine, because when you do cube roots and fourth roots, this is the way you want to go about it. Okay? So I'm just going to do it all the same every time. So then what we're going to do is we're going to rewrite this as the square root of 3 times 3 times 5. Is that okay?
Yeah.
The index is what again?
2.
So that tells you the size of the group you're looking for. We're looking for groups of 2. Is there a group of 2 there? The 3s, okay? So you can circle them if you like circles. Really an oval. Okay? That group can come out front. But the 5 didn't have a partner. So it has to stay inside. And that's your answer right there. 3 radical 5. Okay? Since this is a square root, you could have said, well, I know that this is really the square root of 9 times the square root of 5. We haven't talked about that yet, but that's true. And you could say, well, the square root of 9 is 3. So you can think of it that way as well. But I want you to get used to just going down to its primes and looking for groups, because we're going to change the index. It's going to get bigger. Okay? Everyone knows their first few perfect squares, right? It's 1, 4, 9, 16, etc. But how many perfect cubes do you know? 1, what's the next one? 8, do you know the next one? Okay, so that's the problem, right? This 27 is the next one. But after I get to 125, I don't really know them very easily. Okay, but you don't need to, because that's not how you're going to go about it. And I doubt you even know any perfect force outside of 1. You could think of it. 16 is the first one. But right then they get big pretty quick. 48? I don't think so. All right, so I would stick with doing it this way. Is there any questions on that one? That's negative 2 times the square root of 200. Can we do this problem? Can we do it? Yeah, we can do it. Okay. So we want to get 200 into its primes. Like I said, I'm going to always use a factor tree. You don't have to. But what do you got? What is it? 20 and 10, okay. 5 and 2 over here. 5 and 4. 2 and 2. Is that okay with everybody? All right, so then I want to rewrite this as negative 2 times the square root of what? No. So we're looking for groups of 2s again, or group the size of 2. So how many of those are there? We got that. Is there anything else? We got 2 5s also, okay? Bless you. So this negative 2 is just there. That's part of the problem. And then we can bring this one out. So there's another 2. And then we bring this one out. So there's a 5. Square root of 2. Is that okay? So every group that you can circle comes out as one thing, right? So we had that 2 2s that came out. 2 5s came out. That negative 2 is just part of the problem at the beginning. All right, so, you do want to multiply these together. So that's negative 20 square root of 2. Is that okay? All right, we got 2 more here. What happened there? All right, we can do this one. The index is 2, so we're still going to look for groups of 2. So we're going to break 24 down to what? Okay. And okay, so that means this is negative square root of what? Is that okay?
Where'd you get 3 2s from?
Right, because it was 1 there, 1 there, and 1 there. Okay. All right, we're still looking for groups of 2. Okay, and I'm going to say there's another group of 2 in there. What is it? right? Because what does an exponent say? What does an exponent tell you? So really, x squared, right? The exponent tells you multiply that base by itself that many times. So really, it's telling you how many x's are there, right? Because like she said, this is really x times x. Okay? So if you need to write it out, great. But how many groups of 2 are there? With the x's, Well, just 1, right? So then it's negative 2x square root of what?
3 times 2.
Okay, so you can leave it 3 times 2 if you want. That's perfectly fine. Okay, so 6. But if you left it 3 times 2, that's fine. Okay, if you have everything that is primes and you don't multiply them together on the inside, that's not a big deal. Okay? Is that okay? Anyone got any questions? All right, so far all we've done, right, is square root. So we were looking for groups of 2. But this next one, we got the cube root. So the index is 3. So what size of group are we looking for then? Yeah, there has to be 3 repeated factors for us to group it now. Does that make sense, everybody? Right, that's the whole key to this. Everything else is exactly the same. And once you know what size group you're looking for, it's all the same. We are allowed to do this one, even though there's a negative on the inside, because why? Because it's an odd index. So what I would do on these is I just take care of the negative right away. Okay, this answer is going to be negative something. Okay, so just take it out. Don't try to think of factors of negative anything. Just take the negative out if you're allowed to, okay? And so now we'll just go through with 108.
Hold on.
12 and 9. Okay. What is this one? 2 and 6. What about this one? 3 and 3. And then the 6. Okay. So then really this is negative cube root of 2 times 2 times 3 times 3 times 3. And then an x cubed out there on the end. Oh, I think my fat hand stopped it. Jeez. My hands aren't as limber as you guys because I'm not doing all the phone stuff. That's how you guys benefit from the phone. Nimble hands, thin, if that's what you're going for.
Joey has girl hands.
Go ahead, girl hands. It's all right. Nice and soft.
No, I think you mean like the play. You have the most feminine hands I've ever seen before.
I'm glad I'm getting this recorded.